Hello viewers, in today's class we are going to discuss a very nice integral, right? So in this lecture we'll see how we can solve this integral by making use of the concept of the properties of beta and gamma functions, right? So let us start. So let us call this integral as I, right? Now see, here we have the integral 0 to 1 and the integrand is 1 minus 1 over x raised to 1 over 3. So here we'll see how we can convert this integral into a beta function, and then subsequently we can apply the properties of beta function and the relation between beta and gamma functions and other properties, right? So let us rewrite this integral as 0 to 1, and here we can write 1 minus 1 over x as x minus 1 over x raised to 1 over 3, right? So now let us again simplify it. So we can write it as x minus 1 raised to 1 over 3, and here we have 1 over 3. So distributing this exponent over x minus 1 and x. Now we can write it as 0 to 1, and taking x raised to 1 over 3 to the numerator. So we have minus 1 over 3, and here we have x minus 1 raised to 1 over 3 dx. Now let us write this integral like this: 0 to 1 x raised to minus 1 over 3, and let us take minus 1 common from x minus 1, right? So what we will do here, we'll write x minus 1 as minus 1, and here we can write 1 minus x, right? So here we have minus 1, and then we have 1 minus x, and we can write the exponent 1 over 3. So now we can distribute 1 over 3 over minus 1 and 1 minus x. So we can now write minus 1 raised to 1 over 3 outside the integral, and here we have 0 to 1 x raised to minus 1 over 3 and 1 minus x raised to 1 over 3 dx, right? So here we have taken minus 1 common from x minus 1 in order to convert this integral into a beta function. So now here minus 1 raised to 1 over 3 is equal to minus 1, right? So we can now write minus, then we have 0 to 1, and here we have x raised to minus 1 over 3. So minus 1 over 3 can be written as 2 over 3 minus 1, expressing minus 1 over 3 as 2 over 3 minus 1, and here we have 1 minus x raised to 1 over 3, which can be written as 4 by 3 minus 1, and here we have dx. So now let us apply the definition of beta function. So the beta function is defined as beta m comma n as the integral 0 to 1, and here we have x raised to m minus 1, and here we have 1 minus x raised to n minus 1 dx. So this is the definition of beta function, right, where m and n are greater than 0. So now if we compare this integral with this one, then the value of m is 2 over 3, right, and the value of n is equal to 4 over 3. So now this integral I can be written as a negative, here we have minus sign, and beta of m comma n, because this entire integral is now beta m comma n. M is 2 over 3, n is 4 over 3, right? So now we need to find out the value of this beta function, that is beta of 2 by 3 comma 4 by 3. For this we'll express the beta function in terms of gamma function. So now we know the relation between beta function and gamma function as beta m comma n is equal to gamma n multiplied by gamma n divided by gamma of m plus n, right? So here beta 2 by 3 comma 4 over 3 is given by gamma of 2 by 3. Then we have gamma of 4 by 3 divided by gamma of 2 by 3 plus 4 by 3. So now here we have gamma of 4 by 3, right? And here we have gamma of 2 by 3. Now see here gamma of 4 by 3 can be written as gamma of 1 plus 1 over 3, right? So gamma of 1 plus 1 over 3 can be written as 1 over 3 gamma of 1 over 3, right? So we have written this value of gamma of 4 by 3 like this by using this relation, that is gamma of 1 plus n is equal to n times gamma of n, right? So n is 1 over 3. So 1 plus 1 over 3 is 1 over 3 gamma of 1 over 3, right? And moreover here we have gamma of 2 by 3 plus 4 by 3, which is 2 plus 4 6 over 3, that is gamma of 2, right? And gamma of 2 is equal to 1 factorial, right? And 1 factorial is equal to 1. So here we have used this result, that is gamma of n plus 1 is given by n factorial, right? Okay, so now this expression, it reads like this: gamma of 2 by 3 and gamma of 4 by 3 is 1 over 3, then gamma of 1 over 3, and in the denominator we have 1, right? So this is now it can be written as 1 over 3, then gamma of 1 over 3 and gamma of 2 over 3, right? Okay, now see, we can write this expression as gamma of 1 over 3, and here we have gamma of 2 by 3, which can be written as 1 minus 1 over 3, because 3 ones are 3, 3 minus 1 is 2. So gamma 2 over 3 is 1 minus 1 over 3. So now here again we'll use one important relation from gamma function. So now using the Euler's reflection formula, which says that gamma of n times gamma of 1 minus n is equal to pi divided by sine n pi, right? So now see, here we have gamma of 1 over 3, gamma of 1 minus 1 over 3. So the value of n is 1 over 3, right? So this is gamma n times gamma of 1 minus n, right? N is 1 over 3. So the value of this expression can now be written as pi over sine n pi, right? So we have sine n. N is 1 over 3. So this is pi over 3, right? So this is 1 over 3 pi divided by sine pi by 3. So sine pi by 3 is sine 60 degrees. That is equal to root 3 over 2, right? Now taking 2 to the numerator, we have the value of this expression is equal to 2 pi over 3 times square root of 3. So now our integral I was negative of beta of 2 by 3 comma 4 by 3, and the value of this expression is 2 pi over 3 root 3. So here we have 2 pi over 3 times square root of 3. So viewers, the value of this integral is equal to minus 2 pi divided by 3 times square root of 3. Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from integrals utilizing the properties of beta and gamma functions, right? So in this lecture we'll solve this very important integral which is 0 to 2, and the integrand is x times 8 minus x cube raised to 1 over 3. So let us call this integral as I, right? So let us first see the list of results which are going to be used while solving this important integral. So viewers, we have already solved a lot of problems related to beta and gamma functions in our channel, and in this lecture we'll see this integral. So let us quickly see the results which are going to be used to solve this integral. So the first step is to use this definition of beta function, that is beta m comma n is given by the integral 0 to 1 t raised to m minus 1, and then we have 1 minus t raised to n minus 1, where we have m and n are greater than 0. So this is the important definition which is used in this integral, right? Okay, now let us see the second result. So the second result is the Euler's reflection formula, which is gamma of n. Then we have gamma of 1 minus n is equal to pi divided by sine n pi, where this n is it lies between 0 and 1, right? And the third result is gamma of n plus 1 is given by n factorial, right? Whenever n is a positive integer. And the fourth result is the gamma of n plus 1 is given by n times gamma of n, right? When n is positive and n is not an integer. So these are the four important results which are used in solving this integral. So let us first make the use of substitution method. So here we'll take x cube. This x cube is equal to 8 times t, where t is our new variable, right? So x can be written as 8t raised to 1 over 3. So now 8 can be written as 2 cube, and here we have t, and this is 1 over 3. So now we can cancel this 3 and 3. So we have 2, and then we have t raised to 1 over 3, right? So x is equal to 2t raised to 1 over 3. So now let us differentiate this x with respect to t. So dx over dt is equal to 2 times the derivative of t raised to 1 by 3 is 1 over 3 t raised to 1 over 3 minus 1 using the power rule, and then we have 2 by 3 t raised to minus 2 by 3, right? So now we can write dx is equal to 2 by 3 t raised to minus 2 by 3 and dt. Okay, now see here the limits of integration vary from x is equal to 0 to x is equal to 2, right? So when x is equal to 0, then the value of t can be obtained from this relation, that is x cube is equal to 8t, right? So here we have 0 cube is equal to 8t. So 0 is equal to 8t. So t is equal to 0 by 8, that is equal to 0, right? So when x is 0, t is equal to 0. When x is 2, that is the upper limit. So we have 2 cube is equal to 8 times t. 2 cube is 8, that is equal to 8t. 8 and 8 get cancelled, so we are left with 1, right? So when x is 2, t is equal to 1. So now we can write this integral I in terms of t, right? So we have 0 to 2. So we have 0 to 1. Here we have 0. Here we have 1. Then for x we can write 2t raised to 1 over 3. And then we have 8 minus x cube. X cube is 8t. And then we have 1 over 3, and dx is our 2 by 3. Then we have t raised to minus 2 by 3, and here we have dt, right? Okay, now we can write it as 0 to 1, 2t raised to 1 over 3. And see, here we have t, here also we have t. So the bases are same, so exponents get added. So here we have 1 over 3 plus minus 2 by 3, right? And then we have 2 by 3 here, and then we have 8 minus 8t. So we can take 8 common. So we have 8, 1 minus t, and here we have the exponent 1 over 3. So here we can write 1 over 3 and 1 over 3 over 8, right? So here we have dt. Now 8 raised to 1 over 3 is the cube root of 8, which is 2, right? So here we have 2. So now we can write this integral as 2 times 2 times 2 is 8. 8 over 3. 8 over 3 can be taken outside the integral. We have 0 to 1. Then we have t raised to 1 by 3 minus 2 by 3, which is minus 1 over 3. And then we have 1 minus t raised to 1 over 3, right? So finally, this integral is reduced to this integral by making this substitution. So now let us convert this integral into this form, that is the beta function, right? So we can now write I as 8 over 3. Then we have integral 0 to 1 t raised to minus 1 by 3, right? So minus 1 over 3, it can be written as 2 by 3 minus 1, because 2 by 3 minus 1 is minus 1 over 3. And then we have 1 minus t raised to 1 by 3. Now 1 by 3 should be expressed as n minus 1. So here we have 4 by 3 minus 1, right? And here we have dt. So now this integral is exactly similar to this one, right? So we have 0 to 1, 0 to 1. Then here the variable is t raised to 2 by 3 minus 1, m minus 1, 1 minus t, 1 minus t raised to n minus 1, and 4 by 3 minus 1. So comparing this integral with this one, the value of m is 2 by 3, and the value of n is 4 by 3, right? And both these values are greater than 0. So we can now write I as 8 by 3, and beta function of m comma n, m is 2 by 3, then we have 4 over 3. So now we have to find the value of this function, that is beta function, beta of 2 by 3 comma 4 by 3. Now here we have mentioned only 4 results, but there is one more result, important result, which is used in this integral, and we can name it as the fifth formula, So here we have beta of m comma n is equal to gamma m gamma n divided by gamma of m plus n, right? So this is the fifth result, which is useful in integrating this function from 0 to 2. So now this expression can be written with the help of this result. So we have 8 by 3, then gamma of 2 by 3, gamma of 4 by 3, then we have gamma of 2 by 3 plus 4 by 3, right? So I is now equal to 8 by 3. Then we have here gamma of 2 by 3, and gamma of 4 by 3 can be written as gamma of 1 plus 1 over 3, right? And divided by gamma of 2 plus 4 is 6, 6 over 3 is 2, so we have gamma of 2, right? So now this is 8 by 3, gamma of 2 by 3, gamma of 1 plus 1 over 3. So here I will make use of this result, right? That is gamma of n plus 1. So n is 1 over 3, and here we have 1. So n plus 1, that is n times gamma of n. So we have 1 over 3, gamma of 1 over 3. And gamma of 2 can be written with the help of this result. We have already used this result and this result. So gamma of n plus 1. So gamma 2 can be written as gamma of 1 plus 1, that is equal to 1 factorial, that is 1, right? So here we have 1. So now simplifying it, we have 1 over 3, here 8 over 3, so this is 8 over 9, right? 3 3s are 9, and gamma of 1 by 3 and gamma of 2 by 3, right? So now we are left with this result. So now we'll use this result, which is also known as Euler's reflection formula. So here we can write 8 by 9, gamma of 1 by 3, and gamma of 2 by 3 can be written as 1 minus 1 over 3, right? So we have gamma of n, gamma of 1 minus n, right? N is 1 over 3, and which is obviously it lies between 0 and 1. So 1 by 3 lies between 0 and 1, right? So n is 1 over 3. So here we have 8 by 9, and this expression is now equal to pi divided by sine n pi. So we have pi divided by sine n pi. N is 1 over 3, so we have pi by 3. So this is 8 pi, and here we have 9. Sine pi by 3 is sine 60 degrees, which is square root of 3 over 2, right? So taking 2 to the numerator, we have 2 times 8 pi, that is 16 pi, divided by 9 times square root of 3. So viewers, the value of this integral is given by 16 pi divided by 9 times square root of 3.